This video is to help you understand the difference between and or statements when I have an absolute value with an inequality. I want to make sure that we're using these words correctly because it really actually changes your answer. If I have something is, for example, if I have that it's x is greater than 3 or x is less than negative 4, that's different than saying x is greater than 3 and x is less than negative 4. So just a reminder, or means only one of the inequalities has to be true. The word and means both inequalities have to be true at the same time. So I want to know all of the numbers that are greater than 3, and at the very same time they have to be less than negative 4. Hopefully you realize that there are no numbers that exists. So this is actually a no solution. There are no numbers that satisfy both of those. So let's go back to what we have at hand. X minus 3, the absolute value of that, is less than 6. So that means I am looking for all numbers that are less than 6 units away from 0. So I have a 6 here, and I have a negative 6 here. Now remember, these points, these two areas, are solutions for x minus 3. This is where the x minus 3 is. Okay. Now it says I want all of the numbers that are less than 6 units away. So I want them closer to 0 than 6 units. So that means I'm looking for the inside. If I'm looking for the inside, I'm looking for numbers that are less than 6 and greater than negative 6. Because they're both here, they're both in the same spot. These arrows will intersect one another, and they will cover the same ground. So that tells me this is an and situation. Specifically, it's less than 6, greater than negative 6. I'm sorry, that was a little confusing. It's not an x there. It's not an x that I'm talking about, it's the x minus 3 part. This is an and situation. So when I solve the problem, my final answer will have an and in between. Remember, these and situations can also be written as one inequality. It's only the ands that get to be one inequality. Okay, obviously that's not solved, right? I would actually have to add the 3 to both sides in order to solve this. But I just want to focus on whether something is an and or whether something is an or. Okay, number 2. Again, I'm looking at px plus 1 being less than 3 units away. So here's the 3, here's the negative 3. These 2 points are for x plus 1. I want the x plus 1 to be less than 3 units. So again, I'm on the inside. Less than 3 units. I want like negative 2, negative 1, 0, negative 1 half, positive 1 half, 3/4. All of those points in between there. This is again an and situation, so I can write it as x plus 1 is less than or equal to 3 and x plus 1 is greater than or equal to negative 3. Be sure to use this graph that you've drawn. Use it so you know which way the signs go. This is an and situation, so you could write it as x plus 1 is larger than or equal to negative 3, less than or equal to 3. Side note, mathematicians typically put the lowest number on the left and the highest number on the right, just because that's how a number line is. Okay, next one. X plus 5 is greater than or equal to 6. So, draw my number line. 0, 6, negative 6. This is where the x plus 5 is. Right there and right there. Now, we want x plus 5 to be more than 6 units away. So, would negative 5 be more than 6 units away? No. Negative 7 would, negative 8, negative 9, negative 10. So we are going this way. For the positive side, 5 is not more than 6 units away, but 7, 8, 9, 10, 11, 12, we're going this way. Now think to yourself, can a number ever be in both of these locations at once? Can one number be bigger than 6 and be smaller than negative 6 at the same time? No. So that automatically disqualifies the and. This has to be an or situation. I can't be in both places at once. So that means I've got x plus 5 is bigger than or equal to 6, or the x plus 5 is less than or equal to negative 6. This is an or situation. All greater thans are going to be an or situation because of that. Next one. Okay, x minus 1 is greater than negative 3. Now, in this particular case, we see something special. This part over here is negative. Remember, if I have the absolute value of something is equal to a negative number, we know that can't happen. We know that's a no solution. But for inequalities, do you remember why that's a no solution? I can't have an absolute value, I can't have a distance equal to a negative number. Can't do that. Doesn't work. Okay. But for an inequality, can the distance away from 0 be bigger than a negative number? Absolutely. So even though that inequality sign would indicate an or, we really know that any value for x will work. No matter what you put in there, whether it's 5, or whether it's negative 10, or whether it's 100, maybe it's negative 1/2, they will all produce an absolute value that's greater than a negative 3. It has to be bigger than a negative number. Okay, enough with the tricks. Number 5, last one. Here, the absolute value of x plus 5 is larger than 1. So we're at 1 and negative 1. This right here is where the x plus 5 is. We want the x plus 5 to be bigger than 1. More than 1 unit away from 0. So we're looking for the number 2, 3, 4, 5, 6, so on. We're looking for the number negative 2, negative 3, negative 4, negative 5. That is where the x plus 5 can be. So x plus 5 is less than or equal, not equal to, just less than. Just less than negative 1. Or x plus 5 is greater than 1. It's an or because I can't possibly be in both places at once. A number can't be on this side and on this side. Can't be in both places, so it's going to be an or.